My main area of work is making wetlands work for their money, constructing wetlands and trying to get them to achieve water quality enhancement. Really, they're sort of quiet achievers. Yeah, they get on and doing the job, and they can deal with highly fluctuating loads going into them of wastewater or other sorts of stormwater, and they generally provide, quite an improvement in water quality. In New Zealand, we've lost over 90% of our wetlands, even more in the Waikato, and those sort of ability of wetlands to buffer flows and to clean up water that's going through them as it's passing from the land to the water has been lost in many cases. So now we're looking at targeting wetlands into certain places to deal with some of those diffuse and contaminant loads that are going into waterways. What I'm really trying to do is to quantify how wetlands work, how big do they need to be given a certain flow of waste and type of wastewater going into them, and therefore how to build them, what they'll cost, and what you can achieve with them. Because we know that wetlands are good at removing contaminants, but we don't. But it's like, well, how big does it, if you're actually constructing one, how big does it need to be? What type is the best? How do we optimise that to give us the best performance? Some really interesting work I've been working on recently is applying wetlands into small communities for wastewater treatment. And so some of this has been in Fiji, working on a New Zealand Aid project where we worked with a village to build a wetland treating their wastewater. The village was about 350 people. So those projects are fun because you're working with people and you're seeing the uptake and you're seeing them work with it. And wetlands are great in that way, well-constructed wetlands, because people can sort of understand the treatment processes that are going on in them. Out of the Taunipi catchment in Kivatahi, what we're looking at there is treating agricultural drainage. So this is drainage that comes through what's often called tile drains. You don't really see it. It basically is underground pipes that but what that does is it routes water directly into streams and rivers without any sort of filtration as they go through the soil or through riparian zones. So that can be quite a short circuit of nutrients going directly, and dissolved nutrients going directly into waterways. But what we looked at doing there is putting small wetlands at the end of those drain lines to filter that water before it went out. And relatively simple system. And basically the water passes through a long narrow channel filled with plants and removes nutrients and sediments as it goes through. You really need to look at these systems over a number of years. It's a long-term study, and we've been lucky enough there to work for about 8 years at one site, and also for an extended period at some other sites to see how these systems perform, because every year the drainage flow out of the system is different depending on rainfall and stuff. And so you can get 1 year's results, but then the following year you'll find a completely different pattern and a different result. So that's what's gone into developing guidelines and having these long-term sites where we've been able to get some really good data and actually work out what the average data is and what the fluctuations from year to year are, so that people have actually got a realistic sort of idea of what they can achieve.